Hey everyone, today my team Marcel, Nam, Owen and myself, Preston, we're presenting our project on identifying submarkets using a Bayesian approach. So our partner organization Rex is a real estate tech company, leveraging the power of machine learning to match homeowners and buyers, creating a platform that significantly reduces transaction fees. A couple of motivations for our project. The first one is that the current real estate market is mostly connected through traditional human interactions. So this creates a market opportunity for technology since there is a lot of information asymmetry. Second motivation is that current solutions out there are price indices, which are very noisy metrics because they don't fully and accurately reflect the equilibrium of the dynamics between supply and demand. The third motivation is that these price indices are not very granular because they're usually only at the state or city level and they do not provide clarity to more fine-grained submarkets. So therefore, our proposed model is to predict demand by building a Bayesian submarkets hierarchical model in the Denver market.
So in this study, we used a data set that contains about 250,000 properties that are listed and sold from March 2016 to November 2020. The data comes from three sources. The first is MLS, which provide information on home listing and sale transaction data. The second is Rex dataset, which provide information about the profile of each property. And the last is Census Tract dataset, which is a combination of data from Neighborhood Scout as well as other public census record. To prepare the data for the model, we first combine the features of the three dataset, and then we remove all features that have low variance or miss a lot of data. And then we handpick features that we think will contribute significantly to the model. And then we use the covariance matrix to remove features that are highly correlated with one another. Finally, we use XGBoost to rank the feature importance, and then we keep the top features with the highest prediction gain.
Regarding modeling approaches, as has been mentioned, our aim is to predict the number of homes sold in a submarket and at the market level within a fixed time frame. Originally, we did our baseline model in two categories, a non-submarket and a submarket baseline. And on this poster, we just demonstrate our submarket baseline approaches. To find the optimal number of K submarkets, we use cross-validation over a range of 3 to 20, and we naively assigned kind of homes to a submarket using K-means. And then for each of those K submarkets, we train K distinct models on those discovered submarkets. To look at some of the performance, we can see that on the ratio or predicted to actual homes sold, we get relatively good performance. But on a per home basis, the performance is relatively low, as can be demonstrated by the testing accuracy and the ROC AUC score.
As for our developed model, the distinction that we make from our baseline submarket approaches is that we introduce this variable z sub n to a Bayesian hierarchical structure that is a latent variable encoding a home's submarket membership. And our model, trained through expectation maximization, will identify the parameters relevant to the feature distributions of each home within a particular submarket, and then train a separate model mapping those home features to our output, the probability of whether or not a home was sold within that given time. We note that there is a slight increase in the testing accuracy across both of our hedonic functions, logistic regression and XGBoost, although not a very significant one in this case. But we do have some modest gains in interpretability. And on the right here, we have our display of the submarkets as determined by our model for both the logistic regression and XGBoost hedonic functions. Thank you very much.